to Malik 034 channel. This is Malik Arjun. In my previous session, we saw voting is OCR and OLR and how split brain syndrome scenario can be handled and how the master multi-node scenario can be handled. And one of the common topic, one of the basic topic in any of the cluster-aware environment is fencing. Fencing is nothing but node eviction from the cluster. So what are the basics of this fencing and what are the scenario on which situation node is going to be evicted from the cluster, and then what are the preventive action for this node eviction. So I think I'm going to cover in this topic. First of all, if you are new to my channel, I request you to go back to YouTube and search for Malik034, and then please do subscribe. If you like my video, please like, share and comment. I recently completed the Oracle RAC internal feature series course. So I have covered most of the topics in RAC internals, and all the topics are available in my YouTube channel. Somebody who missed those sessions, so I request them to go back to my channel and then please do watch. So getting started with the today's session, fencing basics. Why nodes are getting evicted? First basic question, like in a cluster nodes are frequently used to see nodes are getting evicted from the cluster. So what is the reason behind that node eviction? Eviction means fencing. Why nodes are getting evicted from the cluster? Is it a good thing or bad thing? So obviously the nodes are evicting from the cluster means people think it is a bad thing. Oh, why I want to lose my node? But in a rack environment, rack world, the fencing is a good thing. It prevents the corruption of data. It prevents the losing our data. So fencing in Oracle world, in Oracle rack, it's a good thing. First you have to remember, fencing happens means you should remember something wrong with my cluster or my setup. So node is evicted from the cluster, it is a good thing. I need to resolve that issue. What is that issue? I need to find out and I need to resolve that. Right, that should be remembered, the first point. The nodes are evicted to prevent the consequences of split brain. Split brain I already explained in my previous session, where both the nodes are not able to communicate each other in the cluster. Where, for example, node 1 and node 2, both the nodes are not able to communicate each other. Both the nodes think as other node is not available, and then I'll become a myself master, and this is also become master, and this is also become master. That is called multi-master node. So to avoid those situation, that is called split brain. So to avoid consequences of that, the node will be evicted from the cluster. Shared data must not be written by independent operating nodes. For example, this node 1 also updating employee table, node 2 also updating employee table, because this is also independent node, this is also independent node. They both will think both are independent node, other nodes are out of the cluster. So both will try to update the same table. So that is a shared data must not be written by independent operation. So this also going to update the same table, this also going to update the same table, same data. So that is going to be data corruption. So in that case, to avoid that, like if both are updating on the same data, so it is kind of this node 1 also updating employee record 1 and his salary 2000, and node 2 also is updating employee record 1 as 2000. So both are updating means it's a corruption in that data. So which one to consider, 1000 or 2000? So to avoid that situation, forcefully cluster is going to evict one of the node, either node 1 or node 2, based upon the analysis. So that is called a node eviction or node fencing. So why and what situation node will be evicted? One will be split brain syndrome. What is split brain syndrome? Cluster nodes are not able to communicate each other, and both the nodes will think itself as a master node, and other node is not available in the cluster. That is called a split brain syndrome. So that is called a multi-node master, multi-master node. Going to the next slide. Stonith. Stonith means what do you mean by Stonith? What do you mean by Stonith means shoot the other node in the head. That is a short form of Stonith. How nodes are evicted? Which nodes are going to evict? For example, node 1 and node 2 both are not able to communicate, because node 1 will ping node 2, node 2 will not send response. Node 2 will ping node 1, node 1 will not send response. Both will not be communicate each other. Both node become master. Like which node to evict? On what basis node is going to evict? Either node 1 will be evicted or node 2 will be evicted. So that analysis will be done using the voting disk. So once we determined either node 1 or node 2, which node to evict, either node 1 or node 2, once which node to be evicted, that is decided, a kill request is sent to the respective node. For example, node 1, I decided node 1 to be evicted, a kill request I'm going to send it. Who are going to send it? Other cluster node will send a kill request to the node 1, and voting disk also is going to send a kill request to the node 1. All the cluster resource will send a kill request to node 1. and then a node CSSD is requested to kill itself. Okay, suppose like I decided node 1 to be evicted from the cluster, node 2 also will send a kill request, and voting disk also send a kill request, other cluster resource also send a kill request to the node 1, and then CSSD of that node service will itself send a kill request, kill itself, and then snownet will happen, shoot in the other node in the head. So this node will be evicted from the. Okay, so similarly in case of node also, if we decided to be a node to be evicted, and then node 1 will send a kill request, voting disk will send a kill request, other cluster resource will send a kill request, and then CSSD of that node itself send a kill itself request. So then this node will be evicted from the cluster. So examples on these fencings, network heartbeat failure. Network heartbeat failure. For example, this is node 1 and node 2. The network heartbeat between the both the nodes are failed. See, node 1 and node 2 now not able to communicate each other. This is the situation. It determined which nodes can still talk to each other. Okay, suppose like we assumed node 2 to be evicted from the cluster, and node 1 will send kill request to the node 1, and other cluster resource also will send a kill request to the node 2, and then voting disk also going to send a kill request to the node 2, and then a kill request is sent to the node to be evicted, that is node 2, and then using all communication channel. All communication channel means from the voting disk, from the other cluster nodes, and from the other cluster resource, everyone will send a node to a kill request. So once kill request we send it to node 2, a node is requested to kill itself, typically CSSD process. This CSSD process will send kill itself request to this node, and then this node will go down. And then what happen if CSSD is stuck? See, suppose all cluster resource send a kill request to the node 2, and then CSSD itself send kill itself request to this node. So in that case, CSSD is supposed to be struck, and it is not able to kill this node. What happens? A node requested to kill itself, CSSD will send a kill request to node 2, but CSSD is struck or is sick or is not able to function properly. In that case, CSSD will fail for some reason, and CSSD is not scheduled within a certain margin. So this CSSD will not function. It is not going to kill this node. So what happened in that case? In that case, there is a new daemon CSSD monitor will take over and execute that kill request, and this node will be evicted from the cluster. So CSSD is struck, and then this particular Mars document will talk about the cluster where node eviction scenarios. So one who interested, please go to Mars document, this particular Mars document, and then please do refer different scenarios and troubleshooting methods. Okay, how can node be evicted? How can node be evicted? So this is one method, CSSD will be evicted from the cluster. Is there any other method can forcefully evict the node in this multi master node scenario or split brain scenario? Is there any way? Yeah, there is a way. Starting from clusterware 11.2 and later version like 12C, 18C, 19C. There's a IPMI. This is optional if you have set up in your clusterware. So that's the intelligent platform management interface. It's a kind of driver, and it's a interface. You can send a kill request forcefully. IPMI allows a remote shutdown of the nodes using additional hardware, a baseboard management control, BMC we can call it as. It's kind of an interface. You can connect remotely to that particular node, and you can send a kill request to that node. So you can forcefully control by manual method also. So this is optional settings if you have configured in your clusterware. So in this node master multi master nodes or split brain syndrome, manually also you can kill the nodes. And the example of IPMI based eviction on the heartbeat failure. Like earlier we saw heartbeat failure and then killing the node using CSSD daemon, and then now using IPMI based killing. So the network heartbeat between both the nodes are failed. Okay, fine. And then we decided node 2 to be evicted from the cluster. It is determined which node can still talk to each other, and then we decided node 2 is a not a good node, and then we need to evict the node 2, and then IPMI used to remotely shut down that node to be evicted. So IPMI, we can connect to this IPMI node 2, and then using IPMI remote connection, so we can shut down this node 2. And then which node get evicted? So we decide, like I used to say that we are going to decide which node to be evicted. So on what basis this on what basis we will decide which node to evict? So for that, voting disk and hardware communication is used to determine the node. So for example, if we have number of n number of nodes, the communication between the nodes, that heartbeat, that is a major, that will play a major role. And then there's a voting disk. Using those two criteria, we will decide which node to be evicted. In two node cluster, the least number of nodes should be survived. And then in the n number of cluster, the biggest subgroup will be evicted. These two scenario I'm going to explain here. Give me a second. I have one more slide here. Okay, I have cluster 1, cluster 2 and cluster 3. Okay, cluster 1 is a 2 node cluster, and cluster 2 is a 3 node cluster, and cluster 3 is a 5 node cluster. In the cluster node 1, if we divide both the cluster nodes 1 and 1, so least is also 1 and highest is also 1. So least node, at any time only one node will be survived and one node will be evicted in the scenario of split brain or multi-master node. That is the reason I mentioned here, in a two node cluster the least node number should be survived. So that is true, because maximum number also 1 and maximum least number also 1. See, for example, if I make it a group, this node 1 will not communicate to node 2, node 2 will not communicate to node 1, and then this is become one group and this is become one group. So least number is also 1 and highest number is also 1. So whichever the least number, it means either 1 or 2, either of 1 will survive in the 2 node cluster. In 3 node cluster, what happens? 1 and 2 able to communicate each other, and 3 is not able to communicate to 2, and 3 is not able to communicate to 1. So that time what happens? 1 and 2 is able to communicate each other. So this 1 and 2 become one group and 3 alone become group 2. So in that case, so my second point will comes into picture. In n node cluster, the biggest subgroup will survive based upon the voting based. So this now biggest group is 1 and 2. This is the biggest group, and group 2 is only one node. This is least group, and this node will be evicted from the cluster, and these two will be survived, because these two nodes will write voting disk, and this is only one is going to write voting disk. So maximum number of written is this group, and least number written is this group. Coming to the cluster 3, 5 node cluster, and then 1, 2, 3 are communicate each other, and 4 and 5 communicate each other, and then 4 and 5 will not communicate to 1 and 2, 3, and this 1, 2, 3 are not able to communicate to 4 and 5. In that case, what happens? 4 and 5 become one group, and 1, 2, 3 become three group. In that case, this all three node will communicate to the cluster voting disk, and this 2 will communicate to the voting disk, which and this group 1 become a highest communication to the voting disk. This will survive, and this group 2 is become least communication to the voting disk, and this node 2, both the node will be evicted from the cluster. So this is what it means here. In two node cluster, whatever the least number of nodes or highest number of node will be survived, and in n number of cluster nodes, the biggest cluster will be survived. That is what we saw in that other slide. So then cluster member can escalate a kill request. So we saw one is heartbeat failure, and then a node will be evicted using CSHD remount, and other one is a heartbeat failure and node will be evicted from the evicted using IPMI. And then other one we saw on what basis, on what criteria we are going to decide which node to be evicted. And now the other way of killing or node eviction is cluster member can escalate to kill a request. The earlier scenario what we saw, node itself is not able to communicate each other. In this scenario, for example, here I have a RACDB instance 1 and RACDB instance 2, and this RACDB instance 1 is not able to communicate to RACDB instance 2. So that time instance 1 will send a kill request to instance 2. So that is like cluster member, example Oracle RAC instance 1 and instance 2 can request what is that? Cluster where to kill a specific member of the cluster. For example, instance 1 will not able to talk to instance 2, though instance 1 will send a kill request to instance 2. Instance 1 kill instance 2, so it will send a request to the instance 2 to be killed. So clusterware will then attempt to kill the requested member. So clusterware service will try to kill the this instance 2. So what happened? Cluster member can escalate the kill request. See, now this node 2 it decided to evict this instance 2 here. So instance 1 is not able to communicate to instance 2, it will send a kill request, and then clusterware will try to kill this instance 2. And then this is okay. Now what happens? One second. Okay, if a requested member kill is unsuccessful, so now that instance 2 where clusterware is trying to kill but it is unsuccessful, a node eviction escalation can be issued. So it is supposed to kill only this instance 2, but this clusterware is not able to shut down this instance 2. That time the node eviction escalation can be issued. So clusterware will issue the node eviction, so which leads to the eviction of the node. So entire node will go down, which particularly member currently resides. So this where instance 2 is resides. So in that case, the if cluster node is escalated, node eviction escalation happened and the entire node goes down, if there are other instance that will be affected because of this rack db1. I have like dev db, I have test db, I have prod db, I have other database instances. So because of this one instance is not able to communicate, so I'm going to lose all other instance. This is one of the demerits. So that how to overcome I will cover in the next slide. Okay, now if the requested member kill is unsuccessful, node eviction escalation can be issued, and then entire node will go down. And then the entire node will go down. Okay, so what happened? So starting with the 11.2, the rebootless node fencing. The earlier, like before this 11.2, fencing means rebooting this cluster node. So starting with the 11.2, rebootless node fencing is came, and that played a very important role. What that mean, rebootless node fencing? So in that mean, like, rather than rebooting this node, I'm shutting down my clusterware OHSD process, and then I'm shutting down all the cluster resource on this node, and I'll keep my node alive. Because if I reboot, for example, if you see here, I have application X and application Y. If I reboot this node, application also I will lose. Only issue with the clusterware, but why should I lose my application? So to avoid that, I'm just shutting down my OHSD clusterware services, and then I'm keeping all other services, all other applications up and running without affecting them. So that is called a rebootless node fetching. Only I will shut down my cluster services. I'm not going to touch any other application, or I'm not going to reboot that node. So that is a rebootless node fencing, starting with the 11.2. Earlier version, fencing means reboot entire node. So until clusterware 11.2, fencing means reboot, and with the clusterware 11.2 and onwards, rebootless will seen. And then right, so starting with this 11.2, reboots will be seen less. Reboot is very less, because fencing is going to be used only rebootless node fencing. So reboot affect application. So if you have other application, that will affect, and that might run a node but not protected, right? So this is impact my application. Customer requirement. So customer will say, I don't want to reboot my node, so I just want my cluster services only to go down. So what is that rebootless means? So just to prevent the reboot, and just to stop the clusterware, and just to stop my OHSD, and just to stop my clusterware services, and then keep other services as it is, and don't reboot my node. Okay, how it works? Rebootless node fencing. How it works with Oracle clusterware 11.2? Reboot will be seen. When it will be seen, instead of fast rebooting the node, graceful shutdown of the stack is attempted. So what happens? How it works? With the graceful shutdown of the stack, graceful shutdown of the OHSD, graceful shutdown of the clusterware services will be sent to node 2, and it will shut down all the clusterware services and all the OHSD process, all the CSFT daemon, all the daemon, everything will be shut down gracefully, and then keeping this node alive and keeping all the other application alive. It starts with a failure. Example, network heartbeat or interconnect failure. So in case of network heartbeat failure or cluster interconnect failure, so we can see this fencing, right? So then IO issue, processes are killed. So the graceful shutdown, what happens when IO issuing processes are killed? It is made sure that no IO process remain. For a rack DB, mainly log writer and DB writer, are the concern. So in this process, all the clusterware stack resource will be done, OHST will be done, all the RACDB processes like log writer, DB writer, all the processes will be killed, and then clusterware will be marked as the reboot flag. So in case if once all IO issuing processes are killed, remaining processes are stopped, and then if the check for the successful kill, so you gracefully shut down this clusterware, and if the check for a successful kill of a IO process fails, then this node will go for reboot. If this check process is successful, then node will not go for reboot. It will make as a OHST process flag as a reboot, and then this node will be still survived. So once all remaining processes are stopped, the stack stops itself with a flag restart flag. So OHST process will make it as a restart flag, and then the node will be still alive, and then all other processes will be stopped. In case this all remaining processes are not able to stop successfully, and then the final signal, the check for a successful kill of IO process is fails, that time this node will go for reboot, because the kill IO process are not able to kill and not able to cleanly shut down my OHST process. So then that time, that is an exceptional case, this node will go for reboot. If it is able to successfully stop all the IO process, then it will not go for reboot, and it will make OHST itself or clusterware stack itself restart flag, and then it will keep remain. OHST will finally attempt to restart the stack after a graceful shutdown. Then after a graceful shutdown, the OHST will start to restart. So what are the exceptional cases? Exceptional cases are if the check for a successful kill after all graceful shutdown, finally it will send this successful kill message. If this kill message is successful, then fine. If this kill message fails, that time this node will go for reboot. If the CSSD will gets killed during the operation, this operation, if the CSSD process is get killed or get struck, that time node will go for reboot. If the CSSD monitor is not scheduled, or CSSD monitor also get struck or get killed during this process, that time node will go for reboot. And if the stack cannot shut down, short disk time, there is a short disk timeout as set, and then within that time we need to shut down my OHST or cluster resource on this one. Within that time, if we are not able to shut down, this node will go for forcefully reboot. So these are the exceptional cases. And then that's it guys for the today's session on the fencing basics, and what are the scenario we can do the fencing, and then how to prevent them, and then starting with the 11.2 how this rebootless node fencing has came and played a major role. So I hope this is pretty informative session, and I believe most of them are not aware of this fencing basics, so this will help your core understanding. If you have any doubts, concerns, please do comment on my YouTube channel on this particular course. So I'm going to answer back to your queries. Thank you guys.